For our next example, we have the integral of 1 over the square root of 1 minus x squared dx. We could try u substitution here, but it's not going to work. And actually, this is an integral that you should be able to recognize straight away. This is just the integral of the arc sine of x. So don't forget the integrals of the inverse trig functions, arc sine, arc cosine, and arc tangent, because those will not work with u substitution, even though those have some x squareds in them, and they might look tempting for u substitution. How about this next one? Next one looks sort of similar, but now u substitution is going to work. If we let u equal 1 minus x squared, du is the derivative of this, is negative 2x dx. I have an x dx right here, but I need a negative 2, so I'll multiply in a negative 2 and divide out a negative 2. So this becomes negative 1/2 times the integral of, so we've got u to the negative 1/2 power from the square root of stuff there, and then du. Now it's just a power rule problem. The negative 1/2 carries down to the next step, times add 1 to the power, negative 1/2 plus 1 is positive 1/2, and multiply by 2, because that's the same as dividing by 1/2, plus a constant. Simplify and substitute back in terms of x. And you have negative quantity 1 minus x squared to the 1/2 power plus c. Next problem, we have e to the 5x, and we want the integral. We know how to integrate e to the x. The integral of e to the x is just e to the x. But how do we integrate e to the 5x? So we'll change it to a u substitution problem. U equals 5x, so du is equal to 5 dx. So we don't have the 5, we need a 5, and we take out the 5 that we put back in. So we have 1/5 the integral of e to the u du. Again, let's highlight it. Here's our du. That's our du. Here is our u. Okay? So the integral of e to the u du is just e to the u. So that leaves us with 1/5 e to the u plus c. U equals 5x. So 1/5 e to the 5x plus c. Now you may be able to do this in your head, and you probably want to do this in your head if you can. Think about it. There's going to be a lot of integrals in your future and a lot of u substitutions in your future, and it'll make your life easier if you can do it in your head. Also, for all of these problems, you can take the derivative of your answer, and you should get the original problem from the derivative. Taking the derivative of 1/5 e to the 5x, it's going to be 1/5 e to the 5x times the inside derivative, which is 5. 5 times the 1/5 cancel out, and you're left with e to the 5x. So we're doing an antiderivative to go to here, but then you can go use a derivative to go backwards. Our next problem is going to work a little bit differently. This one is a problem where u substitution is helpful, but u substitution doesn't give us exactly what we're looking for. Notice the inside function is 1 plus x squared. So if we let u equal 1 plus x squared, du is 2x dx. And you'll notice that we don't have 2x dx. We have x to the 5th, and that is not the same as 2x. So what I'm going to do is I'm going to rewrite this integral a little bit. I'm going to write the integral of square root 1 plus x squared times, and I'm going to put my 2x, I got my 1/2 out front, times x to the 4th dx. So now let's take a look and see what we have. We have our that's not a highlighter. We have our 2x dx right here, 2x dx. We have our u right here, but there are still some x's left over. What are we going to do with these x's that are left over? Well, we need to do something with them. So what we can do is we can rewrite this in terms of x's. So right now it's solved for u. I want to solve it for x squared. U minus 1 is equal to x squared. Well, what I would really like to know is what is u, what is x to the 4th. So u minus 1 to the 2nd is equal to x squared squared, x to the 4th. So now, in place of x to the 4th, I can write u minus 1 squared. This gives us 1/2 the integral of u to the 1/2, the 2x dx, that is part of the du, u minus 1 squared is x to the 4th. So hopefully you see those pieces lining up. Now, this is something I can work with. I can FOIL out u minus 1 squared, distribute the u to the 1/2, and then do a power rule. So that's what I'm going to do. 1/2 the integral of u to the 1/2 times u squared minus 2u plus 1 du. I'm going to run a space here. The integral of, now u squared is 4/2, u to the 4/2. So then when I distribute that in, I'm going to have u to the 5/2 minus 2 u to the 3/2 plus u to the 1/2 du. And now we can do our power rule. We have our 1/2 times u to the 7/2, 2/7, minus 2 u to the 5/2 times 2/5 plus u to the 3, that's a 3, halves, 2/3. And then don't forget plus c. And then the last thing to do to finish this problem would be to substitute in what is u equal to in terms of x. And I guess I could just move this down here. Notice each of these pieces have a 2 in the numerator, so I'm going to cancel, distribute and cancel there. And then I've got 1 plus x squared to the 7/2 over 7 minus 2 times 1 plus x squared to the 5/2 over 5 plus 1 plus x squared to the 3/2 over 3, and then my plus c. So that's the end of that one. That's a nice trick. Even when u substitution doesn't give you exactly what you'd like, you can perhaps FOIL things out and get it to work out.